Today we are going to be finding the intersection of polar graphs. We need to be able to do this in calculus. In calculus, what we're going to be doing is finding the area inside polar curves, sometimes the area between polar curves. We're finding the slope of polar curves, things like that. So definitely need to have a basic knowledge of polars going into calculus. All right. So one of the things we have to do is to find the intersection of two polar curves. And so I can see where these two polar curves intersect. They intersect right there. We're going to be finding the values of theta in between 0 and 2 pi where these two graphs intersect. Okay? So we're finding theta values. Theta values look like that. There's one theta value. There is theta where it is. This is the other theta. We want to find those two thetas. Okay? Visually, though, that's where they are. Okay? Alrighty. So if we're finding where two graphs intersect, we're going to set their two equations equal. They're both are equals, so these two equations will be equal, where 5 cosine of theta is equal to 2 plus cosine theta. So I'm going to take my 5 cosine theta and set it equal to 2 plus cosine theta. I like to write the little word set up here when I'm setting two things equal for some reason. Okay? Just to show what I'm doing. And now we have a trig equation that we can solve. I'm going to subtract cosine theta on both sides. When I subtract cosine theta, I'm going to have 4 cosine theta left over here, and that's equal to 2. Now I'm going to divide both sides by the 4, and cosine theta will be 1/2. Okay? If cosine of theta is 1/2, visually I can see it right here. If cosine of theta is 1/2, what does that theta have to be? Well, that theta has to be pi over 3. What does this theta have to be? It's the pi over 3 angle in quadrant 4, so 5 pi over 3. So those are our two theta values. Okay? Let's do another one. Let's determine the values of theta. We're going to be always finding values of theta here in between 0 and 2 pi where this graph intersects this graph. Well, I can see where they intersect. Theta here will be there and there. Okay? To find it, I'm going to set the two equations equal. So I am setting 4 plus 4 sine theta equal to 2. Okay, and I'm going to solve this for theta. So I'm going to subtract 4 on both sides. We're using what we learned back when we did solving trig equations. When I subtract 4 on both sides, I'm going to get a -2. Okay. Now I'm going to divide both sides by 4, and I get sine of theta is a -1/2. Well, if sine of theta is -1/2, I know my reference angle is going to be pi over 6, but I need the pi over 6 angle in quadrant 3 and in quadrant 4. So theta will be 7 pi over 6 and 11 pi over 6. Those are my two theta values. Not bad? Okay, let's determine the values of theta where these graphs intersect, where these two graphs intersect. So we have this one, which is a 4-petaled rose, and this one, which is a circle centered at the origin. We're still finding the values of theta. We're still between 0 and 2 pi. Well, this time we're going to have lots of intersections, right? We have that intersection, this intersection. How many intersection points do we have? Well, we have 4 petals, and each petal intersects twice. So that's 8 intersections. We need 8 values of theta. I'm going to draw them here. There's some symmetry involved here, right? Okay. So I see I want to get all of those values. And there's definitely some symmetry going on here. Okay, I'm going to set these two equal. So we'll have 8 cosine of 2 theta is equal to 4. Setting that equal. Okay, divide both sides by 8. And we get cosine of 2 theta is 1/2. Remember back when we were solving equations and we solved things like this? You may have wondered, why in the world are we doing this? Well, this is one of the reasons. We needed that tool. We needed to know how to handle that situation. We need it for this. Okay? And next year in calculus, you'll need it when you're finding the area in between these things and stuff like that. Okay? Maybe they are only asking us for that little sliver of an area right there. Well, you're going to need to know that intersection. Things like that. Okay? All right. Okay, so for this one, I know that my reference angle for cosine to be 1/2, my reference angle for cosine is pi over 3. But my angle here is 2 theta. So 2 theta is pi over 3. Okay? 2 theta is pi over 3. And there are more of them. There are an infinite number more of them, right? We only want 8 of them. Okay? True? We only want 8 of them. So, theta here will be, if I divide both sides by 2, theta here will be pi over 6. So this one right here is a pi over 6 angle. So guys, let's use some symmetry. What does that have to be? If this is pi over 6, what is this? Well, I see the symmetry. This is pi over 6, this is pi over 6. Pi over 2 minus pi over 6 is pi over 3. So this angle up here is pi over 3. What is that one then? 2 pi over 3. 5 pi over 6. 7 pi over 6. 4 pi over 3. 5 pi over 3. 11 pi over 6. So as soon as just get this one, and then use your symmetry to get the remaining ones, okay? If you get that one, you can use visually your visual tools to figure out the remaining ones, okay? Let's do another one. In this next one, it says that we will need a calculator. So we will get our calculator out. And they ask us to determine the values of theta again in between 0 and 2 pi. So we will make sure that we are in radian mode. Let's make sure we're in radian mode. Yeah, I'm already in radian mode. I'm also in polar mode. I think I'm going to go back to function mode. Okay? So my calculator is all set, all ready to go. Okay? And we want to know where the graph of this curve intersects the graph of this curve. I can see it. I can see where they intersect. I just need to know what those theta values are. I'm going to go ahead and draw these in so I can use my symmetry. I want you to draw those in so you can see the symmetry there, okay? All right. So I'm going to set these two equal to each other. So 3 minus 2 cosine theta will be equal to 5 plus cosine of theta. I am setting these equal. And I'm going to solve this equation for theta. So I think I'm going to add 2 theta to this side. That will make me get a 3 cosine, add 2 cosine theta to both sides. And that will make me have a 3 cosine theta over here. And I'm going to subtract 5 over. That'll make me have a negative 2 over there, right? And then I have cosine of theta, if I divide both sides by 3, is a negative 2/3. Well, now I know why I need a calculator. I need a calculator because I don't have a reference angle. I don't know the reference angle that makes cosine 2/3, right? So there are two good ways to do this. Two really good ways to do this, okay? I'm going to show you both ways, and then you can decide which way you want to do, okay? The first way to do it is to get just one angle using my inverse cosine function on the calculator. So I'm going to take this calculator, do inverse cosine, negative 2/3, and I get 2.30052 blah blah blah. Okay? Now, when I give my final answer, it'll be only 3 decimal places, but for right now I'm just going to write like that. Okay, so that is this one in quadrant 2. I know it's in quadrant 2 because my calculator would never give me an inverse cosine in quadrant 3. Never, right? For inverse trig functions, quadrant 3 was our black hole. Our calculator would never give us an answer there, okay? However, theta is there. So we need to find a way to figure out what is that theta. Okay, what is that theta? Well, in my mind, here's one way to think of it. Okay, from here to here is 2.3-ish. So to get from here to here, that would be the same thing as starting at 2 pi and subtracting. See the symmetry? I can start at 2 pi and subtract that to get this angle here. So theta, the second theta would be 2 pi minus that, which is 2 pi minus, I'm just going to scroll up, grab that number, 3.98266 dot dot dot. Okay, so my final answers here would be theta is equal to 2.30 or 1 if you round that to the next number. Either 0 or 1 are fine, and 3.982 or 3 because we can round that. Either way is fine. So those are my two answers. Those are my two theta values. Let me show you that second way of getting these two answers. Rather than using your inverse cosine function, rather than doing that, I'm going to go to this equation and put it into my calculator. Cosine x, I'm going to add the 2 pi over the 2/3 to the other side, so make it a plus 2/3. And then in for y2 put 0. So I'm graphing these. I'm going to graph it and see where these two intersect. I only want between 0 and 2 pi. Second calc 5 for intersection. Enter, enter, enter. There's my 2.300. Second calc 5, go over here, enter, enter, enter. There's my 3.983. So both ways are fine. Both ways you have to do a little thinking, okay? I like them both, okay? I know them both. All right. You do whatever method you prefer. Okay? All right, number 5 here. Another calculator one. We want to see where these two intersect. We have that one, and we have this one. Okay? We're finding where this intersects this, so I'm going to set those two equal to each other. Now, if we wanted to use the graphing method, I could just come in right now, don't do a single thing here. Don't do a single thing here like I did up here. Up here I went ahead and got cosine of theta by itself. Here I don't really have to get sine of theta by itself. I could just come right in here, in from my y equals, put 5 minus 2 sine theta, where theta is my x, in for one equation, and 2 plus 3 sine theta, x, in for the other equation, and see where those intersect. My window is still 0 to 2 pi. I may need to change my y's. I think I'm going to have to, well, we'll see. We'll see if I need to change my y's. I'm going to have to change my y's. See, I need to change my y's. If you don't get 0 on one side, you're going to have to change your y's, quite possibly. So I do, however, see where they intersect, but I'm going to increase my y's a bit so I can see it more clearly. I just changed my y's. That's much better. I'm just going to go find those intersection points. Second Calc 5. I'm going to scroll a little bit over here. Enter, enter, enter. And I get theta is equal to 0.644. And I get theta is equal to 2.498. So those are the two values where they intersect. Now, if we wanted to do it the other way, which is fine, I would add 2 sine theta to the other side, subtract 2 to the side, so sine theta would be 3 over 5. So theta would be inverse sine of 3/5, which is, back to my calculator, inverse sine of 3/5 gets me 0.6435 ... which is that 644 number, right? And then, so we found this one, we found that one. How are we going to get this one? How are we going to get it to here? Well, use your symmetry. This was pi minus that number. So I can take pi minus that, so pi minus that number is that 2.498 number. So either way, I get these two numbers. Okay, I like both methods. They're both good. Let's do one more. This one is no calculator, so only use a calculator if it says so in the problem. Otherwise, no calculator. All right? Give me exact answers. The graph of this is shown below. Determine the values of theta between 0 and 2 pi where the graph is at the origin. Where the graph is at the origin. Well, I can see where the graph is at the origin, and I know I'm going to have two answers because it's at the origin twice. No matter how you come at it, we're going to go through the origin twice. So I know I'm going to have two answers. Okay? So, how to find out? Well, the graph is at the origin when r is 0. That's the only way to be at the origin, is if r is 0. It makes sense. That's when we don't go away from the origin, when r is 0. Every other time we're somewhere else. So I'm going to take my 3 minus 6 sine theta and set it equal to 0 this time, and solve for theta. So I'm going to subtract 3 on both sides, divide both sides by negative 6. Sine of theta is 1/2. Well, what values of theta make sine 1/2 between 0 and 2 pi? Pi over 6 and 5 pi over 6 over in quadrant 2. That's it. So that is solving polar, or finding intersection of two polar curves, or finding where a polar curve is at the origin.